It's time to talk about volcanoes. So I'd like for you to look at this central diagram right here in the middle. You see three different definitions. So you see magma chamber is in the center. It's underneath the ground. That's what's holding on to basically what's fueling the volcano. Then you see that when that magma makes its way to the top and it trickles down along the sides, that's when it's called lava. Now this last one is also important. It's pointing to two different places and they're calling them both vents. It's not exactly accurate. So technically, a vent is just an opening in a volcano where it comes out. So if you look here, this, where it's not labeled, would be called the central vent. This over here, if there is an opening, and not all of them do have openings along the side, but over here would be called a side vent, where it would also have like a shortcut to exit the volcano. Whereas this part right here, this central thing that's connecting the magma chamber to the central vent, that is often called the conduit. So it's not located on here, but those would be the more accurate ways to define those. So let's talk about volcanoes. There are actually three major types of mountains. One is called fault block mountains. So fault block mountains, well, there's folded mountains as well. So let's start with folded mountains, actually. So folded mountains is when the tectonic forces squeeze together these rocks, and then because of that, the mountains wind up like warping to one side. That is what's called folded mountains. You could see the folds and the lines in them. If they basically get squeezed together so much that they start to fault and break and crack and then slide down relative to one another, that's what's called fault block mountains. Both of those are caused by tectonic forces squeezing together. The third type, volcanic mountains, is not formed in that way at all. We'll talk about volcano formation later. A volcano is a mountain that forms when molten rock, called magma, is forced to the Earth's surface. And you could see a very clear observation of it right here. So you can see how the lava trickles down along the side of this volcano. On this volcano over here, you can see that there's basically no lava to be seen. Instead, in this explosive eruption, you could see what's called pyroclastic material, which is this super hot jet of gas and ash and dust all zooming upwards really high into the air, much higher than this eruption over here. This is a truly explosive eruption going very high. Now notice in all three of these pictures, it's all an isolated one single mountain that's just by itself. And that's the majority of how a lot of these volcanoes are formed in comparison to a lot of other mountain ranges that look different, because there's like a whole other slew of volcanoes, or sorry, mountain tops there as well. On this bottom left one, you can see that it is also a volcano, but this is sometimes referred to as either an extinct or dormant volcano because it's not active right now. So that means it's like temporarily like sleeping of sorts, and it could erupt again in the future, or perhaps it's just no longer going to erupt, in which case it would be extinct. But you may notice that it's snowy at the top and nowhere else. And this is like a trick that mountains kind of pull, because they're one of the only things that this happens where you could be at the base of the mountain and you could be like, it could be a really hot day out where you have shorts on, short sleeve shirt, and it's hot out, right? But at the top, it is freezing cold, so cold that it needs, that has snow that exists on there, and that can exist within the same summer day. And the difference of that is just altitude or elevation. So the higher up you get into the atmosphere, the colder it gets, because there's less air the higher up you go. So the higher up you go, there's less air, and because there's less air, it's less possible for the air molecules to basically rub against each other, and then there isn't as much of a transfer of heat. So even though you're closer to the sun, technically, it's actually still much colder up there, because the more layers of air you have, the further down you go, closer to the surface of the Earth. It's like you're more wearing more layers of air, and that's really what clothes do. They just trap your own body heat against you. So there's more air molecules down closer to the surface of the Earth because gravity's pulling them all down, and there's just less of that as you get further up. So that's why, in general, colder places tend to be in places of higher elevation. So the study of volcanoes is called volcanology. And all of these three people are volcanologists. And you can see that they all have slightly different masks and things that they're wearing and instruments that they're using. So this person actually obviously has a gas mask. These people are much closer to them. So they actually have like this protective hood and this suit that basically is like a heat shield as they descend to get closer to the lava. And this person actually he basically has this probe that's going right into the magma where they can get a readout and get some data based on, what is it made out of, what's the temperature like, its composition, all sorts of things that a volcanologist might be interested in. Here's a volcanologist that is very dedicated to his craft. You have to admire that, not even flinching when his shoes and his tripod seems to catch on fire. I'm hoping that he notices very soon and runs away and dusts off all that fire so that he can live to Volcanologist another day. Here's an incredible video of a volcano diver where he descends into a pit, a crater, if you will, and gets some just breathtaking footage of it. It's one of my favorite videos that I show all year. All right, time to talk a little bit more about lava. Lava is simply magma that flows onto the Earth's surface. So that's really the only difference between that and magma. Now, if you have a pit of lava right over here, some people have argued, well, is this lava? Is this magma? I would argue that if you can see it, because this is technically the Earth's surface right here, it's still considered to be lava. And deep down inside of the ground is where the magma would really be. So you can see here that this person is pressing down on it with his foot, and this is it's starting to cool on the outside. So this is very slow flowing lava. This is much faster flowing lava down here. And as this cools down over here, you might be saying, well, how was he able to press down on it at all? And the reason for that is basically that the human body is less dense than liquid rock, which is what it's made out of, liquid rock. So that's why when it presses down, it just sits right on top of it. Now it can catch on fire, but it's not going to sink down inside of it in the way that a denser material would. If you ever were curious if it was possible to make lava, it is, and this video can show you exactly how.